Hang on.
Since for any Republican president.
Now, there's something strange going on because I was live a bit ago and I can't see the video anywhere. It's just vanished. I'm really... YouTube keeps making my videos disappear. I don't know why. Let me just make sure that this is live. Refresh. So I did this video. It was about 16 minutes long. And... Right, okay, that's live now. So what the heck's going on? I was live earlier and I can't find the video anywhere. I've been looking for it on my YouTube channel and it's not there. I don't get it. I don't get it at all. Is it going to load? So I've got to do this again because I can't find the video. Right, I'll mute myself. I'm going to monitor it this time to make sure. Oh, okay, so what I was explaining in the previous video, which I can't find anywhere, is I think there's some hope with that design. Let me just, I'm getting dizzy now because I'm seeing alcohol in my eye. So I took this apart and the hub inside had broken off. The little plastic stem that the drive shaft goes through, it had snapped off. Well, it was cracked, so I stuck it back together with acetone. And so that there's actually a lot less wobble on, as in side to side, as in this direction. It doesn't wobble as badly now. It was really bad before. It was wobbling really crazily when I was turning it, because the hub had broken, so the shaft was pivoting on just the bottom section of the wheel, so it wasn't being held true very well. So that's probably why it was so badly out of balance. So anyway, I sorted that out. Now what I wanted to explain is, I'll put this over there because I'm going to have to do all this again. So you remember I designed these screens for the magnetic flux, which I was intending to block the magnetic field when the ball passed the first magnet. The idea was that it would screen it. Well, that's not necessary, obviously. What we do need to do though is harvest more flux in the direction where I want it to go, because the ball is omnidirectional. So when the steel ball's in there, what's happening is the flux is being dissipated in all angles. Because omnidirectional means that it's not focused in one particular direction. It means it's basically scattered everywhere. So it's like a light bulb, right? A light bulb shines light in all directions if it's a round globe. Well, this is what's happening with the ball. We need to focus the flux so that it's only going towards the coil, so we get better coupling. So what I was thinking of, and I'll show you on the other side, was what we need to do is design a lamination array where the flux is guided in an arc, so that as the wheel is turning, the flux is guided towards the central axis point of the coil, and so that when it is top dead center of the magnet, the flux is basically top dead center of the coil. But then as this moves away from the magnet, we need another arc of steel laminations, or shims. I'm going to use shims actually because I've got plenty of those. What's happened to my finger? Oh, I don't know, I've got some crap on it. So then we can, so that as this lamination assembly passes the central point, it will basically be in the center where it will be cancelled out, because there won't be any laminations there. So then as it continues to rotate, these laminations will be opposite the coil, and they will actually intersect with the other magnet over here. So what I was thinking about doing, it's annoying having to do all this again. I just don't know what happened to my video. I really don't know. So what you have to do, I was thinking about doing, is creating some inserts which will sit inside the wheel, so that I can create the lamination. Well, I'm not going to use, I'm just going to use them steel things I've already got hundreds of, loads and loads of laminations out of this steel panel, these things. Remember, I took them all out, most of them. I've got absolutely loads of these things. So some of these are still in the panel there. So I can use these as my, because I measured them, they're exactly the right length, width for the wheel. So if I take this off again, see if I can get this undone with one hand. Right, so I've got all these steel shims which I can use because they're exactly the right length. If I get my wheel, you'll see what I mean. If I put them on the wheel there, you'll see that, oops, it's going to fall off. It's the right height. So I can have a bunch of these. What I was thinking about doing was, I'll just move it out of the way, standing them on their end through the slot. So instead of using these balls to guide the flux, I was going to stand them like Legos, just like Legos. So I could have them too thick, side by side, to make it thicker, stand them all the way to make an arc like this along this line to carry the flux from this magnet to the edge where it would pass the coil. So it would save me a lot of messing about because I don't need to cut them. I can just create a slot, a piece that goes in this section, for example, where a series of slots where I just drop them in and the flux would carry all the way to the edge in an arc, and do the same on this side. And then as the wheel is rotating, it will engage the flux to the coil, and then this other one would pass this other magnet. It would be at the right point when it's passing this other magnet on the exit point. So I'd get a more focused field, a magnetic field going all the way to the coil, so it should be much better than using the steel ball. And I don't want to use a nanocrystalline material, which is over there. I don't want to use that because it would, if it's scrapped later on, I end up with a load of wasted nanocrystalline material, and that stuff's, yeah, it's hard to get. My friend sent it to me. I'd rather hang on to it for a usable project which has huge potential and that's going to do the job. So that's my thoughts, and that's what I'm thinking about doing. And the next time I go live, I'm probably going to model something from the computer showing how I'm going to incorporate that into the wheel, because I don't want to keep printing new wheels. I want to try and use the existing wheel and just have an insert that goes into this part here. The trouble is, on my wheel that I printed, I've got these guides for the shielding which I put in, so I'm going to have to cut them out with my chisel. It's not too difficult to do. Cut them out with my chisel because they're facing the wrong way. The parts that are close together want to be on the inside. So just to give you an idea what I'm thinking right now, I kind of came to this idea earlier today, and it would be more effective because instead of the flux just basically passing through the ball and for a moment only just catching the outside perimeter of the coil before it hits top dead center, which is in the middle where there's no flux at all, where it's directly opposite the coil. Instead of having that situation, the flux is going to travel around an arc, so it will be traveling towards the central point of the coil. So by adjusting the arc, which is what I've got to do in the SketchUp model, so that this basically is in the center point of the coil, and then as it passes the next magnet, the other arc will be from this magnet to the central point of the coil. So that way we get maximum coupling to our coil, and we can also get more voltage and current, hopefully. That's the objective. So instead of it being omnidirectional, it'll be travelling along that arc towards the coil in a straight line. Well, not a straight line, an arc shape. And the flux is arced anyway, so yeah, flux tends to arc around anyway. So yeah, so that's the idea. And I'm hoping that this video is going to work this time, because earlier on I was looking for YouTube trying to find it and I can't find it anywhere. I don't know what happened. I think something must have gone wrong. Well, I'm watching it live right now on my computer, so I'm definitely streaming, so what the heck happened? I just don't know. Yeah, the mysteries of YouTube does strange things sometimes. Anyway, that's the plan. I've got to model that in SketchUp, and I want to, if possible, do inserts which I can just slot into the existing wheel with the arc already in, so I can take it out, put a different one in with a different arc, and try it out with different configurations. So instead of having to print a whole wheel every time, I can just print the sections that go into these things, and I could probably drill a hole or something in the middle to screw a screw with a washer on it to hold that thing in place so it doesn't fall out. So I won't need the cover anymore. The cover that I've got on there at the moment will have to come off. I'll just get my knife and remove it that way. So I think it's going to get pretty interesting. Obviously the balancing issue won't be a bigger problem because these laser cut pieces of shim, they're all exactly the same because they were cut on the laser. So as long as I use the same amount on each one, it should be in balance. The only balance problem might be is the wheel is not perfectly round, but oh well, we'll figure that out. I'll have to. What I'm going to have to do is balance the wheel without it being near these magnets, because whenever there's material in here, it attracts to the magnets, and I can't really balance it properly. So I'm going to need to balance this wheel out without any material in it on a different shaft and get it running true before I actually start putting my shims in. And if I print the holders that hold the shims in place, 3 of them, they'll all be exactly the same. So in theory, they should, when I slot them into these slots, they should all have the same balance. So we should knock that out. It shouldn't get knocked out of alignment. Right, I think that's it. I think I covered the next stage of the test jig, because that's all it really is. It's not practically going to be generating power for us at the moment. It's just to test the theories out. And as I say, there does seem to be some promise there, because the test I was timing on the stopwatch, it was inconclusive. It didn't really give me a solid conclusion as to that the drag was actually slowing it down. You know, in one situation we actually got 3 minutes and 23 seconds, which is under load, which was kind of surprising actually to me. So yeah, it'll be interesting to try something else that doesn't use a lot of print plastic and all that. Right, okay, that's it for now. Hopefully this is going to work this time.